In this video, we're going to do a quick review of linear functions. A linear function in two variables, x and y, is any equation that may be written in the form y equal mx plus b. Now in this form, m is going to represent the slope of the line, and b will give you the y-intercept. In fact, the y-intercept will be 0b. And our slope is, by definition, the difference in y values over the difference in x values, or y2 minus y1 over x2 minus x1. And we call y equal mx plus b the slope-intercept form of the equation. We can also say that the slope of the line is the ratio of how far up you move divided by how far to the right you move when you go from one point to another point on the line. Here's an example of how we use the slope and y-intercept. We have the equation y equal 2/3 x minus 1. Our slope is 2/3 and our y-intercept is 0, -1. We plot the y-intercept 0, -1. We move up 2 and over 3 to the right to get another point of 3, 1, and those 2 points give us enough points to graph our line. And here's how we deal with negative slope. Let's say we have a slope of negative a over b. We could interpret that as negative a over positive b, which would mean we'd go down a units and then right b units. And we could also interpret negative a over b as a over negative b, which would mean we'd move up a units and left b units. So for negative we go down or left. For positive we go up or right. If we must move both down and left from moving from point to point, the two negative signs in our slope make the slope into a positive value. And here's an example of a graph with negative slope. We have y equal negative 2x plus 1. Our y-intercept is 0, 1. Our slope is negative 2, and we interpret negative 2 as going down 2 units and to the right 1 unit, and that gives us the point 1, -1. We could also interpret that slope of negative 2 as 2 over -1, which would mean we'd go up 2 and left 1, and that would give us a point of -1, 3 on our graph, and I show it right up here in the corner. Now we're going to look at something that's really important in this unit, and that is the point slope form. This allows us to find the equation of line given 2 points. And the point slope form is m times x minus x1 equals y minus y1, where x1, y1 is any specific point given on the line, and the x and y refer to any generic point that is a solution point on the line. Let's look at an example. Let's say we have a line with slope m equals 3, and it passes through this specific point 4, -1. Well, 4, -1 is our x1, y1, and 3 is our slope m. So we plug those values into that point slope form given here, and we get 3 times x minus 4 equals y minus -1. That simplifies to 3 times the quantity x minus 4 equal y plus 1. And we can rewrite that in slope-intercept form as y equals 3x minus 13. Now we can check our work here. We have the slope-intercept form, 3x minus 13. 3 is our slope, which is what it should be. We plug in that point that we were given, 4, -1, to see if it works. When we plug in 4 in 3x minus 13, we get 12 minus 13. And that makes -1 our y value, so it all checks out. All our work was correct. Now we'll do an example where we use that point slope form to find the equation of the line given just 2 points on the line. And here we have the points 4, -1 and 2, -2. From these 2 points we can get our equation. First we get our slope, and we use the 2 points, plug them into the slope formula, y2 minus y1 over x2 minus x1, and we get -2 minus a -1 over 2 minus 4. That gives us a slope of -1 over -2, and that's a slope of +1/2. So we have our slope, and we have 2 points, we only need 1 point. So we're going to pick one of those 2 points. I'm going to choose 4, -1 to be my x1, y1. So I'm going to plug that x1, y1 and the slope into the point slope form m times quantity x minus x1 equal y minus y1. And we get 1/2 times the quantity x minus 4 equals y minus a -1. And if we multiply through by a half and add to both sides to get y by itself, we get the slope-intercept form of y equal 1/2 x minus 3. To check our work, plug both 4, -1 and 2, -2 into that slope-intercept form. If you plug in 4, -1, you get 1/2 times 4 minus 3 equals 2 minus 3 or -1. If we plug in 2, -2, we get 1/2 times 2 is 1 minus 3 is -2. Both points check out, and that verifies that we did get the correct answer. Now let's just cover a few facts about parallel and perpendicular lines. Parallel lines are lines with the same slope. You can tell if lines are parallel by looking at their slope-intercept form. Here's 2 examples. We have y equal 3x minus 2 and y equal 3x plus 100. These lines are parallel because both lines have a slope of 3. 3x minus 2 is slope 3. 3x plus 100 is slope 3. Perpendicular lines have slopes that are negative reciprocals of each other. Here we have an example. Y equal 3/2 x, which has a slope of 3/2, and another line y equal -2/3 x, which has a slope of -2/3. These slopes are negatives of each other and reciprocals of each other. So these are perpendicular lines, and I have both lines plotted below here. In one line, we go up 3 and over 2 to get another point. In the other line, we go down 2 over 3 to the right to get another point. And that geometric relationship always gives us perpendicular lines. And now let's take a look at horizontal and vertical lines. Horizontal lines have a slope of m equals 0, and they have the form y equal k, where k is the y value of every point on that horizontal line. Vertical lines have slope undefined, and they have the form x equal k, where k is the x value of every point on that vertical line. And here's a few examples. In the first example, we graph the line passing through 2, 1 and 2, 3 and find its slope, and then find its equation. Well, we graph that line, and clearly it's a vertical line. And if we try and find the slope, we get 3 minus 1 over 2 minus 2 is 2 divided by 0. Well, that's undefined. So we really can't use the point slope form because we have no slope. We just have to remember that it has the form x equal k. In this case, k is 2, so our equation is x equals 2. In a second example, we're going to graph the line passing through 2, 1 and 0, -1, find its slope, and then find its equation. Well, we plot these 2 points and the line, and clearly we get a horizontal line. And when we find the slope, we get 1 minus 1 over 0 minus 2 is 0 over -2, or 0. So our slope is 0. We can use the point slope form for this equation, but it's a whole lot easier just to remember that it's a horizontal line with the form y equal k, where k is the y value of all the points on the line. In this case, k is 1, so our equation is y equals 1. And now we're going to do a 2-part example that uses most of the concepts we've covered in this section. We'll find the equation of a line that has a graph parallel to the graph of the line given by 3x plus y equals 6, and also passes through the point 2, -1. And we'll also find the equation of a line that has a graph perpendicular to that same given graph 3x plus y equals 6 and passes through that same point 2, -1. And to find the equation of any line, we need 2 things. We need the slope and we need 1 point. And once we have the slope and 1 point, we can plug those values into the point slope form m times x minus x1 equals y minus y1. Well, we have our x1, y1. It's the given point, 2, -1. So we have that component. Now we just need the slope in each part. In the first part, we want to find a line parallel to 3x plus y equals 6. Well, that means it has the same slope as 3x plus y equals 6. To find that slope, we just rewrite 3x plus y equals 6 in slope-intercept form. When we rewrite 3x plus y equals 6 in slope-intercept form, we get y equal negative 3x plus 6. That means our given line has slope negative 3, and that's going to be the slope of our parallel line. It will be m equal negative 3. Now we can plug those quantities into our point slope form. So we plug in our value, m equal negative 3, and our point into the point slope form, and we get negative 3 times quantity x minus 2 equals y minus a negative 1. Simplify that to negative 3 times the quantity x minus 2 equal y plus 1. Then we can solve that for y to get it in slope-intercept form using the distributive property and subtracting 1 on both sides, and we get y equal negative 3x plus 5 for our part A. Now, in part B, we have to use the line perpendicular to the given line, and if it's perpendicular, it means it has the negative reciprocal slope. Well, after we rewrote the given line in slope-intercept form, we got y equal negative 3x plus 6. So that means the perpendicular line will have a slope that is the negative reciprocal of negative 3, which is positive 1/3. So we plug 1/3 and 2 negative 1 into the point slope form, and we get 1/3 times the quantity x minus 2 equals y minus a negative 1. And that simplifies to 1/3 times the quantity x minus 2 equal y plus 1. And we can rewrite that in slope-intercept form as y equals 1/3 x minus 5/3. Now the way we can check these answers, both of these answers, is to plug our point 2, negative 1 into both equations. You should get a true statement, and you do indeed get a true statement, so our solutions were correct.